In the previous section, we looked at derivatives for sum and difference, power rules, exponentials. Now we're going to look at a rule for a product of two different functions. So I have the derivative of two different functions, some function f times a function g. And I would like to know what that derivative is. So I'm going to come up with a rule for that. Notice how it is very interesting. It's not just the derivative times the derivative. It's the derivative of one times the other one plane. Then the other one plane times the derivative of the one. Let's see why this happens. We can discuss why this happens by looking at the proof. And once we look at the proof and we understand why it works this way, then we can use it. We have some big function, capital F, let's call it, and it is two functions multiplied together. I would like to know the derivative of this big function, so I'll use limit as h goes to 0 of f of, would have to be capital F of x plus h minus capital F of x all over h. And I used capital F's because if I used an H, then I have H in the bottom, so I couldn't use that one. Irregardless, let's keep rolling. Limit as h goes to 0. So I'm going to replace my x's with x plus h here. So this would be f of x plus h times g of x plus h minus just the plain function, which is f of x times g of x all over h. This really won't get us anything, but we pull a little trick, and this little trick is, we call it adding a chicken and taking out a chicken. If I were to add 1 and subtract 1, I get the same thing. So I'm going to add and subtract both the same thing in the numerator so I can get things to collect nicely. And it is a devious little trick. So I've got this guy here, and I add and subtract something that I know what I want. So I'm going to subtract f of x g of x plus h, and there's actually, I could subtract it the other way too, but I could do g of x and f of x plus h, but whatever, regardless of whatever it is you're doing, you have to add and subtract the same thing. Once you've got that in, then we're going to be able to collect some terms. So that's supposed to be f of x, g of x, all over, this is stunning, h. So I'm going to look at the collection of this and the collection of this and see what they have in common. So is the limit as h goes to 0 of, I notice that these two guys have a g of x plus h in common. Okay, I'm going to take out this g of x plus h and both of those two terms only. So I've got f of x plus h minus f of x. Of course, the stuff is all over h. So there's this wad of junk. Plus, and these two terms have an f of x in common. So I will say f of x times, then I get g of x plus h minus g of x. Okay. Then I'm going to split up, this is messy and long, I'm going to split up that limit into some. So I'll have the limit h goes to 0 of g of x plus h using all of my limit laws here to the maximum ability, which is the limit as h goes to 0 of this. I'm going to put the h over top of this guy. Added with, notice that that's all multiplication. I'm going to play the same game here, but this one will need his own limit. The limit as h goes to 0 of f of x times the limit as h goes to 0 of this, and this is where my h will go. It has to go somewhere, and you can't put two of them, otherwise it'd be an h squared, notice. This side will be g of x plus h minus g of x. Chink, chink, chink. Replacing now, if I replace h with 0, this is just g of x. This thing, can't really do much with it, but it is f prime. Plus, replacing h with 0, that's f of x. This thing can't do much with it, but it is g prime. And there's the product rule right there. Now how can I use that? Well, let's just say f of x happened to be, let's say, x squared plus 3x minus 2 times, how about 4x cubed minus 3. Normally, using my previous rules, what I would have to do is multiply all of this out and then do the individual terms. But using this product rule, if I say that this part is, let's say, f of x, and let's call this g of x, scroll up because I'll need more room, f prime of x would be, they tell me to write one of them down, so I'll write down my g, 4x cubed minus 3 times the derivative of the f. That would be 2x plus 3 plus the plain old f, x squared plus 3x minus 2 times the derivative of the g, 12x squared. Oh, that's it, because that other one's a constant. Cool. And that would be the derivative. I went ahead and wrote out the product rule for this f of x times g of x so that we didn't have to flip back. I wrote it up there at the top. So I'm going to call this one f. I'm going to call this thing right here my g. So let's get the derivative. So this equals, tells me to take the derivative of f. That would be 2v, leave the g alone, 2 square root v plus 1. Add to that just the plain old f times the derivative of the g. Now on the g, I'm going to look at g as 2v to the 1/2 power plus 1, so I can use my power rule. And I would have 2 times 1/2, that's 1, v to the negative 1/2. And then that would drop because it's a constant. I need to combine any like terms that I can. So 2v times 2 square root of v, probably should have multiplied that out, plus, I was just looking at this guy, that would be like 4/2 plus 1/2, so that'd be v to the 3/2. And making this one look similar, let's just say that's to the 1/2 power, and this would be to the 2/2 power because it's to the first. So this would be 4v to the, looks like that'll be 3/2, plus 2v plus v to the 3/2. So in total I have 5v to the 3/2 plus 2v. Now I've said before, what you really need to do is leave your answer in terms of how it was given. Since this is given as a radical, I'll write this as 5 and then square root of v to the third plus 2v. And that'd be typically how you'd leave your answer. Alright, let's go for the derivative on the second one. I'm going to say that this is my f and this is my g. If I want the derivative, I take the derivative of my f, that's 2x, times just the g plane, that would be e to the x. Add to that the f plane, that's the x squared, times the derivative of g, that is e to the x. Alright. I guess if I wanted to, I could leave that as an answer if I wanted to. Might look prettier to do this. Pull out the e to the x, 2x plus x squared. That would be a fine answer. I could also have pulled out an x, so I could say x e to the x 2 plus x. That looks pretty cool. I think that's my favorite way to leave this answer. Alright, the proof of the quotient rule, so we can use the quotient rule. Look at the big old mess that thing is, so we can figure out what he is and then how to use him. Let's just say I have some quotient. We'll call it q of x equals f of x over g of x. Well, I could rewrite this as f of x equals q of x, g of x. If I do this, then I can just use the product rule. F prime of x equals, alright, the product rule tells me that would be the derivative of one of them times the other one plane. Add to that, now he's plane, and it's the derivative of the other one. Okay, well, I don't really care about f prime of x. What I'm really looking for is q prime of x, so I'm going to get that on a side all by himself and move this junk over to the other side. So I'll get q, that's not a q, q prime of x, g of x equals, moving u, oops, I'm going to move this side over to the other side so I don't have to deal with so many negatives, minus q of x, g prime of x. Well, if you'll remember, q of x is this deal right here. So I'm going to be replacing q with what he really is. And I'll get q prime of x equals g of x. And that's going to be f prime of x minus f of x over g of x times g prime of x. I like to get this all as one big common denominator. You're all over one thing because you're multiplied, and I need you to be in that same denominator, so I'm going to multiply here by top and bottom of g of x over g of x, so I can do my normal fraction thing at a common denominator and add. Oops, this must be a times. Okay, keep rolling. Q prime of x times g of x. It's not even a g, I don't know why I keep doing that, g of x, there we go, equals, so I'll have f prime of x, g of x, minus f of x, g prime of x, all over, because I'm subtracting, I keep the same denominator and just subtract the top, so this is just plain g of x in the denominator. I'm going to divide both sides by this g of x. And now I know what q is. Q is, I can see both those two things at the same time. I can't do it. I'll just do it from here. You go out of there. Q prime of x equals f prime of x, g of x minus f of x g prime of x g of x. Now this is something you'll have to have memorized, and it seems like a lot, but some people like the little mnemonic low d high minus high d low all over, because that's supposed to be squared, low, low. So it's the low one times the derivative of the high one minus high derivative of the low all over low, low. Low d high minus high d low all over low, low. Remember it however you want to, but you are going to have that. You'll do it so much you'll have it memorized eventually. And if you don't want to keep looking back at it over and over again, just remember low d high minus high d low all over low, low. Okay, I've written the quotient rule up here. So let's call this top one F, bottom one G. Let's see what this equals. Okay, the low one, that's the G. X squared minus 1 times the derivative of the top one, 2x plus 3 minus the top one, x squared plus 3x plus 4 times the derivative of the low one, 2x all over x squared minus 1 quantity squared. After this, it's a matter of algebra, and yes, you have to collect your like terms. I'm going to do that. Here's what I get after multiplying. Seems to me that this x cubed term walks away, leaving me with negative 3x squared minus 10x minus 3. At this point, you want to see if you have something that will cancel, because you see that the denominator will factor, but I wouldn't have anything that would cancel, so I'm actually done. 1 over e to the x. That way I can use the quotient rule where there's my f, and it would be much easier. Take the g, write it down, e to the x times the derivative of the numerator. Derivative of the numerator is a 0, so that's times 0. That term is going to be gone, minus the numerator, which is a 1, times the derivative of the denominator, which is just e to the x, all over the denominator squared, so e to the x quantity squared. This would be, you're gone, negative e to the x over power raised to power. What do? I would multiply my exponents. So it'd be e to the 2x. When I have same base and I have exponents, I can subtract exponents, leaving me with, or you could say that there's 2 of these e to the x's in the denominator. Anyway, this is what I end up with, because I subtract exponents.